In this video, we're going to do an example using Lagrange multipliers to find maximum and minimum values of a function subject to a constraint. So the function that we're interested in is f of xy equals e to the xy. We want to find the maximum and minimum values of this function subject to x cubed plus y cubed equals 16. So we take our partials of f with respect to x and y and set them equal to the same constant times as the partials with respect to x and y for our g function. Because this, again, the first two equations are giving us that the gradient of f is some scalar times the gradient of y. That's where the first two equations are coming from. And then we want it subject to this constraint, so our constraint is our third equation. All right, so if either x or y is 0, well, if x is 0, say x is 0, well then from this equation, lambda is equal to 0, right? Or y is equal to 0. Well, if y is equal to 0, we don't get something that satisfies the constraint equation. If lambda is equal to 0, we go back up to the first equation. That tells us y has to be 0, and again doesn't satisfy the constraint. So again, if one of them is 0, the other also has to be 0, but that doesn't satisfy the constraint. So we're going to assume that both our x and our y are not equal to 0. What that does for us is it allows us to solve for lambda by dividing by those things with the variables in it. So we get y e to the xy equals 3x over, y e to the xy over 3x squared equals x e to the xy over 3x squared. Excuse me, 3y squared. And if we manipulate this particular equation, we get x cubed equals y cubed, which also implies that x equals y. In any event, that gives us that 2x cubed, plugging in, say, x equal to y here, gives us 16, so x cubed is 8, tells us x is 2, which at the same time means that y is 2. All right, so we can certainly find values of x and y that are opposites of each other that satisfy the constraint equation. So I'll give you a specific example here. I can take negative 2 cube root of 2 for x and 2 cube root of 4 for y, and I'll get something to satisfy that. In any event, no matter what happens, I can make my x be as big, say, big negative as I want, and my y as big a big positive that I want, which means that I'm taking e to a really, really big number, which means it gets smaller and smaller and smaller. I'm getting values that are smaller and smaller. So there's no minimum value because I never actually hit 0. So there's no minimum value here. That means when I plug in the 0.22, I'm getting a maximum value. And if I put in the 0.22, I get e to the 4th.